So welcome to this lecture. In the previous lecture we discussed about the representation of discrete time signals. For example, we discussed about the impulse response and how the impulse response we can compare with the other type of signals, or how the operation happens with the help of this impulse that we discussed in the previous lecture. So on continuing on that, so we actually drawn different signals, x of n and del of n we drawn, x of minus 2 del of n plus 2 we already drawn, x of 1 and del of n minus 1 we drawn, x of 2 and del of n minus 2 we drawn. Now we represent this signal as a combination of all these things. So x of n can be represented like this: x of minus 2 del of n plus 2 plus x of minus 1 del of n plus 1 plus x of 0 del of n plus x of 1 del of n minus 1 plus x of 2 del of n minus 2, etc. So general form is like this: summation of k varies from 1 to minus infinity to plus infinite x of n into del of n minus k. If you substitute here, you will get the same equation only. Okay, so this equation we represent in a general form like this. So here, where del of n minus k is the unit impulse for n is equal to k, and this is exists only for n is equal to k and 0 for all other n. Okay, so that's the general representation of impulse response in terms of discrete domain. Now there is look at this question. Represent the sequence of x of n 3 2 minus 1 2 4 1 as a sum of shifted unit impulse. Okay, so this is the question. So first write the question: x of n equal to within a set it is 3 2 minus 1 2 4 1. Okay, so here you can see an arrow. Okay, this arrow indicates the 0th position. Okay, so this arrow indicates the 0th position. Right side of this arrow is from 0 1, first position, second position, third position, like that. Left side of this arrow minus 1 minus 2 minus 1th position, second position, like that. So this is the center. So whenever in a question you find an arrow, then you should assume that this is the 0th position. In a question, if there is no arrow indicated in the question, at that time you have to take the first position as the 0th position. Like that you have to analyze. So luckily in this question they are directly given the arrow, and it is in the second position. So this is arrow. So we can say that this is the 0th position. So this is the first position, second position, third position, fourth position. And left of this arrow it is the minus 1 position. So it is minus 1. So how to write the general term? So we know that x of minus 1, this is x of n, various values of x of n is this. So we know that x of minus 1, when n become, this is the position, nth position, when it become minus 1, x of minus 1, what is the value? 3. When n becomes 0, x of 0, what is the value? 2. When n become 1, x of 1, what is the value? Minus 1. Now when n become 2, x of 2, what is the value? 2. N become 3, x of 3 is 4, x of 4 is 1, like that it is going. So we have value from minus 1 to 4. So in general equation we know that x of n equal to k varies from minus infinity to plus infinite x of k del of n minus k. You know the general equation. So substitute the values into this equation. So we know that k varies from minus infinity to plus infinity. Here it is 1 to 4, means 1 to 4, minus 1 to 4. That means it varies from minus 1 to 4. x of k del of n minus k. Okay, so x of k, you put the values of k here. So x of minus 1 del of k become minus 1, that become minus plus 1. So del of n plus 1. Next you put k equal to 0, next value minus 1, next value 0, x of 0 del of n, that is x of 0 del of n plus. Now put the value 1, x of n del of n minus 1, x of 2 del of n minus 2, etc. like that it is going. Okay. Now so it reaches to x of 4 and del of n into del of n minus 4. Why? Because the final value is 4 here. So you know the values of x of minus 7, x of 0, x of 1, x of 2, x of 3, x of 4. Substitute the values of these x terms to here. So x of minus 1 is nothing but 3. So 3 into del of, put 3 here. Why? Because here it is 3. 3 into del of n plus 1 is 3 del of n plus 1 plus 2 del of n minus del of n minus 1 plus del of n minus 2 plus 4 into del of n minus 3 plus del of n minus 2. So this is the general representation. In that we have substitute the values of x of values. So x of 1 is 3 into del of n minus 1. Here x of 0 value is 2. Next x of 1 value is 2. X of 2 value is 2. X of 3 value is 4. X of 4 value is 1. You substitute here, you will get the final equation, final answer. Okay. So now the next term is impulse response and convolution. So you look at here, this is the x of n, impulse input. This is the system. Here you give input x of n, this is the system, and you will get a output y of n. Output, this is the output, this is the input, this is the system, this is the output. So what is output here? We can write output is equal to t of x of n. This is the system response. Okay, this t represents the system response. So output is equal to system response into x of n. So t into x of n. See, a discrete time system performs an operation of an input signal based on a predetermined criteria to produce a modified output signal. So discrete time system, the system performs an operation on the input signal based on its predetermined criteria to produce a modified output signal. If the input to the system is x of n, output is y of n, and then the transform operation is like this: y of n equal to t x of n. Okay, this is the transform operation, this t. So y of n is equal to t into x of n. If input to the system is a unit impulse, then output is the impulse response denoted by h of n. See, if this input x of n is impulse, that means our delta of n, then what will be the output? It is called impulse response. So if the input to the system is unit impulse, then output impulse response is denoted as h of n. So h of n, how can we write h of n? Output response, we know that y of n equal to t into x of n. Here y of n is nothing but output response. Here input is impulse, so x of n is nothing but del of n. T, output is impulse response. Impulse response is represented by h of n. So you can write h of n equal to t into del of n, t of del n. So this is general equation. X of n, we know that k varies from minus infinity to plus infinite, x of k del of n minus k, and y of n equal to t, summation k varies from minus infinity to plus infinite, x of k del of n minus k. This is x of n. You put y of n. What is y of n? T into x of n, t of x of n. T is a transformation function. So t into x of n. What is x of n? This time we substitute here. Okay, then take this, you take the transform inside. Y of n equal to summation of k varies from minus infinity to plus infinite, x of k into t into del of n minus k. What is t into del of n minus k? T into del of n is nothing but h of n. So t into del of n minus k is nothing but h of n minus k. So you can write, instead of this t into del of n minus k, you can put it as h of n minus k. So y of n is nothing but summation k varies from minus infinity to plus infinite, x of k, h of n minus k. Clear? So the output of the LTI system, of an LTI means linear time invariant system, is given by the weighted sum of the shifted response. So what is the output of an LTI system? It is the weighted sum of the, it's actually a summation, no? It is the weighted sum of the shifted response. So this here n minus k means there is a shift operation and a weighted sum. So this is the output. Output of an LTI system is given by weighted sum of time shifted response. So this is the convolutional sum. This convolution sum can be represented as y of n equal to x of n convol this symbol, star symbol, normally we call it as convolution symbol. Okay, so y of n is equal to x of n convolution h of n. Now look at a problem. Okay, we'll discuss the problem in next lecture.